Quantum computers could break all encryption, putting passwords, bank accounts, and even national security at risk. How close are we to this digital doomsday? And can we stop it? Stay ahead of the future. Subscribe now, and let's dive in. Quantum computing, the end of encryption? Introduction. A digital arms race begins. In the not-so-distant future, a technological revolution looms on the horizon, one that threatens to dismantle the very fabric of digital security. Quantum computing, once a theoretical marvel, is inching closer to reality. But as scientists and engineers push the boundaries of computation, another group anxiously watches: cybersecurity experts. The question is no longer if, but when, quantum computing will break encryption as we know it. The digital vault's under siege right now. Powerful entities, nation-states, cybercriminals, intelligence agencies are engaged in a clandestine practice known as Store Now, Decrypt Later, SNDL. They're intercepting and stockpiling encrypted data, personal passwords, financial transactions, government intelligence, and corporate trade secrets. Today, this data is unreadable. But within the next decade or two, when quantum computers become powerful enough, these stockpiled files will be cracked open in seconds, exposing secrets that were once deemed impenetrable. The implications are massive. Imagine financial institutions collapsing overnight, military secrets laid bare, and entire economies thrown into chaos. The encryption methods that have protected our digital infrastructure for decades will be rendered useless. How quantum computers threaten encryption. To understand why quantum computing poses such a dire threat, we need to explore how traditional encryption works. Since the 1970s, digital security has relied on asymmetric encryption, particularly the RSA algorithm, named after its inventors Rivest, Shamir, and Adleman. The security of RSA encryption is based on the complexity of prime factorization, the process of breaking a large number into its two prime factors. With classical computers, factoring a 300-digit number would take millions of years, making RSA an effective safeguard. However, in 1994, mathematician Peter Shor developed an algorithm that, when run on a quantum computer, could factor large numbers exponentially faster than any classical computer. This algorithm, known as Shor's algorithm, poses a direct threat to RSA encryption. With a sufficiently powerful quantum computer, encryption keys that would take classical computers millions of years to crack could be broken within minutes. The mechanics of quantum supremacy. At the heart of quantum computing lies a radical departure from classical computing principles. While classical computers operate using bits, which exist in binary states, 0 or 1, quantum computers use qubits, which can exist in superposition, holding both 0 and 1 simultaneously. This unique property allows quantum computers to perform multiple calculations at once. But quantum supremacy isn't just about superposition. It also relies on entanglement, a phenomenon where qubits become interconnected, meaning the state of one qubit instantly affects another, no matter how far apart they are. These principles allow quantum computers to solve complex mathematical problems like prime factorization at breakneck speeds. The race for quantum security, governments and tech giants are not standing idly by. Aware of the looming quantum threat, agencies like the National Institute of Standards and Technology, NIST, are racing to develop post-quantum cryptography, PQC, new encryption methods designed to withstand quantum attacks. Among the leading PQC candidates are lattice-based cryptography, uses complex mathematical structures that even quantum computers struggle to break. Multivariate cryptography relies on solving nonlinear equations, which quantum algorithms can't easily process. Hash-based cryptography uses cryptographic hash functions, a method immune to quantum attacks. In 2022, the U.S. government began urging federal agencies to transition to quantum-resistant cryptography, acknowledging that quantum decryption is a when, not an if. A timeline to the quantum apocalypse. Experts estimate that a fully functional quantum computer capable of breaking encryption could emerge within 10 to 20 years. However, even today, the threat is real due to SNDL. The next few decades will determine whether cybersecurity experts can stay ahead of the curve, or if quantum hackers will unleash a digital catastrophe. The future of encryption in a quantum world. While quantum computing threatens classical encryption, it also offers solutions. Researchers are exploring quantum key distribution, QKD, a method that uses quantum mechanics to create encryption keys that are theoretically unbreakable. The laws of physics dictate that any attempt to intercept a QKD transmission will alter the key, making eavesdropping detectable. Meanwhile, businesses and individuals must prepare for the quantum shift by adopting hybrid encryption models that combine classical and quantum-resistant cryptography. The best defense is proactive adaptation. Conclusion: a call to digital vigilance. The dawn of quantum computing represents both an unprecedented opportunity and an existential threat. It promises breakthroughs in medicine, materials science, and artificial intelligence, but also poses a fundamental challenge to cybersecurity. As quantum supremacy draws nearer, the question remains, will humanity rise to the occasion and secure its digital future, or will we be caught unprepared in the greatest cyber war of all time? The race against time has begun, and in this high-stakes battle, preparation is our only shield. Quantum computing is no longer just a futuristic concept. It's a reality that will redefine cybersecurity as we know it. With traditional encryption on the brink of obsolescence, the race is on to develop quantum-resistant cryptography. Governments, tech giants, and cybersecurity experts are already preparing for a post-quantum world. The question is, are we ready? If you found this video insightful, don't forget to like, share, and subscribe for more deep dives into the world of science and technology.